Hello, everybody. Thanks to join this webinar. Today we will talk about the medium voltage and low voltage critical electric asset monitoring, specifically designed for the hotspot temperature measurement, partial discharge detection, and humidity and ambient temperature. My name is Simone Meneghin. I am a regional sales area manager for Altanova. Together with me is present my colleague, Eric Castillo. He will take the word in the last part of the speech. He will explain to everybody some customer experience that in the past were using successfully this kind of solution.
A pleasure.
So this is the summary of the speech. We will start telling something about the causes, the most typical causes of failure. Then we will see how the monitoring system is composed. We will say something about the measurement principle of our sensors. What are the capabilities of the system? We will see some detail regarding the setup and the construction and the layout of the solution. And in the end, we will see few customer experiences. Okay, if we think to a medium voltage asset, we most of the time find a bus bar and a cable termination. These two metallic parts are connected together with a bolt. Through this bus bar and cable termination is flowing the load current. But if one of the bolt is not well tight, the impedance here in this position is high enough to produce heat. And if the temperature of this point is going up, this can be dangerous for the asset. Another reason to have a very high temperature at these connection points is due to the load current. If the load current is too high in respect to the rated current of the cubicle, this is a critical situation because the temperature here can become very high. This cause of failure is called thermal breakdown. Not only the load current, also the operating voltage can be the stimulation of some other problems. For example, if there is a defect into the insulation material, I'm imagining the insulation material around the conductor of the cable, this can be a source of, for example, partial discharge. If these partial discharges are detected in advance, it's possible to predict a possible failure. Another reason of failure can be an air dielectric breakdown. If there is humidity into the cubicle, we have also always to remember that there is a high voltage here in the cubicle, and the humidity in the air can create some conductive path where some of these discharges can travel. If this happens, most typically we have surface and corona discharges. This black line represents the metallic enclosure of the cubicle at the ground potential. So these kind of discharges are between a high potential part and a ground potential part. These are real cases. So this is a picture took in the past where a thermal breakdown causes what you can see in the picture. This is what happened in case of insulation defect, and this is a nice picture of a surface discharge. You can see the pattern here. There is a discharge that was creating here on the surface of this current transformer. So these are the failure that we need to avoid, and the monitoring system is the best solution you can adopt. Typically, the spot measurement are not typically. Sometimes the spot measurement is the method that people use to keep under control the status of your asset. You can do the temperature measurement through an infrared camera and partial discharge detection with handheld devices. But this is not an activity you do every day. Maybe you do twice per year. In my example, you can see one measurement in April and the second in October. But using this approach, the risk is that a fault may occur between the two spot measurements. And the only way to avoid this unwanted situation is to place permanent sensors. The permanent sensors give you measurement always. They are available every day for all the year and during the whole 24 hours per day. Another good point for the continue online monitoring is that the measurements are made inside the cubicle and not outside. This increases a lot the reliability of the measurement. If you get measurements with a good sample rate, let's say one measurement every 15 minutes, you can set up the alarm logic based on trends. We have to remember that the most important parameter is the increasing of the temperature or the increasing of the partial discharge activity. And be able to issue an alarm based on the trends is very important. Last but not least, a monitoring system does not need an operator. So you don't need to occupy the time of a single operator or more than one operator that are walking around the substation with handheld devices doing the measurement. So these are the four main points, four main reasons to switch from spot measurement to continue online monitoring. Our system is composed by sensors. This is one of the sensors for the hotspot, the temperature of the hotspot. Then we have a sensor for humidity and ambient temperature. We have an antenna because our sensors are wireless. So there is not the need to connect a wire between this kind of sensor and the antenna. The antenna is also a partial discharge detector. So these three elements are the sensor of the systems. Then there is a reader that is a measurement concentrator. So all the antennas will be connected to the reader. And the reader can be connected to a local HMI. On the screen, you can directly see all the measurement live. Into the local HMI is possible also to insert a reader. So there is a version with and a version without a built-in reader inside. Let's see more in detail how the system is created, starting from an example for medium voltage switchgear. So in this representation, we find the medium voltage compartment of the switchgear, the busbar of the three phases, and the cable termination of the three phases. On the bolt is screwed the hotspot temperature sensors. So this is very important because the temperature is directly measured on the critical point. It's not measured from the outside with an infrared camera. There is an antenna as I said you before, this antenna is here to detect the signals, the measurement from the wireless sensors. And also, this is a partial discharge detector. The antenna is mounted on the inside the cubicle by means of magnets or another type of connection. But mainly, the magnets are the method used to connect the antenna to the cubicle. Then it's possible to place the humidity and ambient temperature sensor somewhere inside the medium voltage compartment. It's important to say that these sensors and antenna must be placed inside a metal enclosure. It's important because of the working principle of our sensors. Typically, there is a low voltage compartment where, for example, protection relays are placed. In this low voltage compartment, we can put the local HMI. Then, two wires from the humidity sensor and the antenna are going from the medium voltage compartment to the low voltage compartment in order to bring the information to the local HMI. It was an example for a single panel, but the number of panels can be any. And in this representation, you can see a possible representation for 3 panels. So every cubicle has three sensors for the temperature, 1 antenna, 1 humidity sensor. The reader is one here in the middle that take the measurement from these 2 antenna, and everything is then collected into the local HMI. The operator can watch on this screen, into a single screen, all the values of all the 3 cubicles. So this is very convenient. But in case of more cubicle and maybe placed in different rooms of your substations or your plant, in this representation, there are 4 rooms. You can decide according to the distances between the cubicles and the general layout of the plant where to place readers and the local HMI. The local HMI can communicate to an already present RTU or SCADA all the measurement, and then from the RTU to SCADA, all the information can be sent to a control room. So the situation can be always under control from the control room. So this is another even better way than send an operator to read directly on the local HMI to keep under control a large number of panels. Now we see a little bit more in detail possible solution for medium voltage switchgears, medium voltage dry transformers, and low voltage switchgears. Okay, this is a sketch that represents a real medium voltage switchgear. So we can see the busbar. On the busbar, we can place 3 sensors because this is also important to be monitored. Here is the circuit breaker input, circuit breaker output, cable connections. Local HMI into the low voltage compartment. So you can see the number of hotspot temperature sensor is 12 because this is the maximum number of sensor you can place inside. You have to know that every 3 sensor you need to install 1 antenna. So in case of 12 sensors, the number of antenna is 4. And these 4 antennas will be connected to a single local HMI. To the local HMI, it's possible to connect up to 8 humidity and ambient temperature sensors. This is a picture of a real installation. These are the first 3 sensors placed on the circuit breaker input, and this is the antenna that will take the signal from these 3. This is the circuit breaker output, so 3 more sensors and the second antenna. You have to note that these 3 sensors are screwed here on the bus bar, and the other 3 are not screwed but connected through a sort of a plastic belt. So according to the conditions, the placement and the connection of the sensor must be evaluated. And again, must be noted that sensors and antenna must be placed inside the same metallic enclosure. Temperature, antenna, and don't forget that antenna is also a partial discharge detector of the partial discharge activity inside this metallic enclosure. This is a humidity sensor. You can see is placed on the bottom of the cubicle, but can be placed also in other positions. So according to the most convenient place, you can put the humidity sensor. And again, between sensors, temperature sensor and antenna, there is no wires. The only wire is going from the antenna to the low voltage compartment by means of this plastic tube. In case of a medium voltage drain transformer, the most frequent causes of failure is the deposit of dust on the resin, and also the creation of micro cracks due to the thermal cycles given by different temperature coefficients of the windings and the resin. These 2 phenomena reduce quite a lot the remaining life of the dry type transformer. So it's always good to keep under control the partial discharge activity. So for this kind of asset, is very recommended to perform the partial discharges monitoring. These pictures are for another type of transformer. In this case, these pictures are taken from an oil transformer, and these are the termination box, medium voltage side and low voltage side. In the yellow circle, you can see the temperature sensors. And this and this are the 2 antennas. The sensors are wireless, so we have also to take into account the maximum distance between the sensor and the antenna. Actually, we have more than 1 model of SAW sensors, so according to the model, the distance will change. This is specifically designed for medium voltage asset, and the maximum distance from the antenna is 200 centimeters, 2 meters. But there is another type called the low profile sensor that is more compact. This is very suitable in a situation where the space constraint is an issue, but this bring to a shorter maximum distance to the antenna. You can see is 50 centimeters. From the antenna to the reader, you can place a cable whose length is maximum 7 meters. This cable is a radio frequency coaxial cable. There is another type of sensor. In this case, is not a wireless sensor. In this case, there is a wire. this is specific design for low voltage switch gears. See, there is a wire, maximum 25 centimeter, between the three sensors, and then there is a, as before, a 7-meter radio frequency cable from one of the sensor to the reader. Few pictures that show real installations. These are the low profile sensor. You see this kind of sensor can be placed on the circuit breaker arm directly. This is the only solution in this case, and this is also something we can provide. And these are sensors for the low voltage breakers. So this is the sensor you saw before in the picture, but we also have other models with other shape and layout in order to fit as better as possible into your asset. Few words about the measurement principle. SAW stands for surface acoustic wave, and as the name suggests, we are talking about mechanical waves. So the antenna continuously sends stimulus, and this stimulus is propagating along the metallic enclosure. That's why sensor and antenna must remain the same mechanical enclosure, because we need to provide a path for the waves to travel. So this stimulus reach the sensors, and this sensor will answer with two specific frequencies. And the distance, the difference between these two frequencies is the measurement of the temperature of the hot spot. Since this is based on mechanical principles, you know, when a conductor, or in general a material is, you apply a higher temperature to a material, it expands. And this reflects into a different resonant frequency of the sensor itself. So you can see the dependency of the resonance frequency with the temperature. So long story short, according to the temperature, the resonant frequency change, and the difference between these two signals is the measurement of the temperature. The biggest advantage of a SAW sensor is the high reliability, because they are passive. No active parts can fail. This brings not only high reliability, but also an extended lifetime. So one of these sensors can really live in your asset for many, many years. Few more words for the partial discharges. So when a partial discharge event happens, it causes a broadband ultra high frequency emission that are picked up by our antenna. The bandwidth of the signal that is propagating is very wide, but our sensors works into 3 specific band, and that you can see here in this list. So what we do with this antenna is to pick up this partial discharge activity by measuring the emission into these 3 specific bands. This is a real measurement. This is the time, so the horizontal axis is the time, and the vertical axis represent the charge of the partial discharge. The first and second graph are for partial discharge measurement, and here you see the temperature and the humidity trend. We see here an increase of the partial discharge activity. This brings an alarm, and if you don't take any action, if you don't apply corrections, the result will be most probably a failure in your asset. This real measurement belongs to this real asset. You can see how it is damaged. So this partial discharge activity was due to this defect in the asset. So you see the period here. This is July, and this is February. If you remember the discussion regarding the frequency of the hotspot measurement, the evolution of the fault is around 1 month here, and nobody expects to do a spot measurement every second day. So this is to say once again that the monitoring system is protecting you from this kind of event. So when the fault has an evolution in 1 month, with spot measurement, it's very difficult to be able to see this trend. Okay, the CAM5 and the reader has very interesting features. So first of all, the configuration of the system must be performed here, but this also is responsible for the collection of data from the reader, is doing data elaboration, is calculating trend, and also store all the measurements, and in the end, it provides alarm according to the settings you decide to put in. So you need a laptop with a very easy software tool, a few screenshots here. You have to set up the maximum temperature. If you measure more than the maximum temperature, then you decide to issue an alarm. But also, if there is a difference between, for example, two phases, you can you can set an alarm because of the difference of temperature of two sensors. And on the reader, you can program, you can set up, and also calibrate every single temperature sensor. So everything is managed by a very easy software tool that you can install in your laptop. All the measurements are available in numerical format, so table with numbers, but also in graphical formats. So this is the time. This is, for example, a partial discharge activity, and these are temperatures over the time. So you can switch from the numerical format and the graphical format with just one click on the local HMI. This is a picture of the rear panel of CAM5. There is a USB port where is placed a USB stick. So every 15 minutes, an acquisition is done and automatically saved into this USB stick. And the value are saved into a CSV format. And this is very convenient for two reasons. First of all, is a safe data backup of all your measurement. So whatever happened to the system, you always have a backup into this stick. And you are also in the position to perform your own analysis. The analysis are performed by the CAM itself, but if you need some insight or to adapt the measurement to your already existing criteria, you can do it. So it is a CSV file, easy to handle. This expands the capability of the system, providing this CSV file. When an alarm must be issued, it can be communicated to the outside world by means of emails, but you have to put in your plant a GSM router. So the CAM5 can send an email to your laptop, or through Modbus or the commutation of dry contacts, the alarm can be communicated to the SCADA or RTU, and this device will transfer the alarm to the control room. So these two are the most used way to send the alarm outside. Okay, a few more details to give a better picture about the system, something that must be known when you decide to install the system. Since we are installing parts on high voltage termination, it's very important to keep the distance between metallic parts. So there are two distances. One is between conductors, and one is between conductors and metallic part at ground potential. So in this table, you can see that according to the operating voltage, the distance to be kept must be increased. Okay. So what you have to be aware of is that there is a minimum distance to be respected between sensors and metallic parts. But there are also some maximum length and distance to be respected. So you don't have to go more than these values. So from the temperature sensor, the antenna, you have maximum 2 meters. And from the antenna to the reader, maximum 7 meters. The readers can be connecting daisy chain, and the total length of this daisy chain is 1,000 meters. From the CAM to RTU, we can go using Ethernet cables. Ethernet cables, the maximum length is 90 meters, or using fiber optic, but must be multi-mode fiber. Then the distance can be up to 3 kilometers. Communication protocols. So from the sensor to the antenna, there is the surface acoustic wave. So actually, it's not a communication protocol; is a principle. Then from the antenna to the reader, you have to connect with a coaxial cable for radio frequency. From the humidity sensor, you use the I2C protocol. The reader communicates to the CAM5 using the Modbus RTU, RS485, and from the CAM to the SCADA, we can use a Modbus RTU slave, Modbus TCP, and if you have special requests, we can manage also the DNP3 or the IEC 650, but these two needs a extra license to be implemented. This is an example of a maximum expansion because the single reader can be connected up to 4 antennas, but in this example, I decided to put up to 3 just to underline the fact that we don't have to exceed 7 meters. This cable cannot be more than 7 meters. So in case of a large number of cubicle to be monitored, our suggestion is to keep maximum 3 antenna per each reader. And the maximum number of reader per each CAM is 9, plus 1 that is built in. The power supply of the system is only for reader and cam. So just to say once again, the antenna and the sensors do not need power supply, but the reader, yes, it needs a voltage, CC voltage in this range, and the CAM5 also in this range. You can find here indicated in the slide. This picture gives you an idea on the space occupation of the reader. You see it's a very small device placed in the low voltage compartment of a cubicle. In this space, you can also put the local HMI. But in case it's not possible to place the CAM5 inside here, because there is no space or you are not allowed to modify, we can provide a box like this. So it's an external box where the CAM5 and all the ancillary components can be placed in order to give the possibility to have the local HMI in your plant. Okay, so my general explanation on the solution provided by INTELLISAW is over. So I leave the word now to my colleague Eric Castillo. He will now explain some customer experience that we had in the past. So Eric.
Thank you. You can hear me good, right?
Yes.
Okay. You can pass the slide, please, because I think I can. So INTELLISAW has had many experiences into different industries, and it includes utility companies within US and other countries globally. In this case, we have the situation of peak demand plant that will need to be powering up on demand. So what happens in these cases is that we may have humidity accumulation. If it's a high humidity environment over the medium voltage assets. This may cause corrosion, and with the corrosion, we will have heat and increased degradation of the system. So, click further. It's a bit slow. So our system will be helping to monitor at the generator circuit breaker at the inputs and outputs, so we can see issues from the bushings. This particular case, we had the deterioration of 4 of the bushings of the GCB, which is the photo that you see below on the right. That is an actual photo of how it looked after we serviced it. The main situation here is that we were able to make a scheduled scheduled shutdown, not having to wait until we have a critical situation. Into the next slide, we will see the data that we pulled from the system. And so it had a progressive increase in the temperature. It rose over the 105 degrees Celsius that IEC has as a limit for copper tin plate. And there was also a differential between the phases on the temperature. So it is getting into a problematic temperature, and also there is the possibility of detecting situations within the three phases. So again, with this, we were able to schedule ahead. I think it was 2 months in advance of the situation, and make a scheduled shutdown. This is one of the cases. If we move into next, which is published as a chemical company known for many of us, BASF. In our case, normally our system has a very good payoff. The system itself, it's low cost if we compare it to the installed asset cost, and if we also compare it to the shutdown that it prevents, it's much higher, the difference. This particular case, we were looking into a two transformer system, and which is composed of two transformers that have a primary and a secondary. There is a bus ducts along them and into a switchgear lineup. The gasket failure that was detected, we had intrusion of humidity. So when the customer that made his testimonial, he said the shutdown that I would have done with this, it would have affected my whole system. It's a system that costs over $1 million. So our system it's very low in comparison to the switchgear itself and to the impact that it has. If into the next case. So those two cases are related to the operating condition, to having a good predictive maintenance. This case of Brazil, a Brazilian aluminum producer, their plant, they did not have you can click on the rest of the points, Simone, please. The plant itself was not, or was able to work at a higher production rate because they did not know how much they could demand performance of the plant. In this case, the rectifier stacks is a very noisy environment. Actually, into the questions, I think someone asked about the wireless system, how it works within a very high noise electromagnetic field. This is a very particular case because we have 100 kiloamperes rating on the rectifier stacks, and that is a challenge to work with and whatever electronic system. So the SAW temperature monitoring system, it worked good, and it allowed the customer to increase the operating current at 10%. That means that it's a higher production rate that they could spend because they were not sure if they demanded more from the system, if it would begin to fail. So this was the way of verifying that. So again, this is a different case where it's not just the maintenance or having a better assessment of situations that are coming and doing a shutdown from it. In this case, we are able to produce more from the measurements that we get. Obviously, for partial discharge, because of the rectifier stacks, we use UHF. So it is not case to verify for partial discharge. This is temperature only. So those are a couple of the many cases that we got. We have been working actively and deployed over 30,000 systems globally into various customers of whatever medium voltage and also low voltage, which is more new assets that they have, because it's not the process, but the type of assets. It's switchgears, it's bus ducts, it's transformers, it's rectifier or capacitor banks, any application that is metally enclosed for the wireless sensors. So we got commercial, very known customers globally, and the OEMs also are here. Are just a very small sample of the ones that we work with globally into different regions. We're active into Asia, Middle East, Latin America, Europe, you name it. And we have done the testing with them on their switchgear, so it's characterized. We normally will ask for information on the assets, specifics, if necessary, if there are no references, because each manufacturer has many switchgears. But again, it's something that we have assessed already. That is what I had. Simone?
Okay, Eric, thanks for your very useful information you provide to us. Okay, so we are now in the end of this presentation. Remember that we have a website, the one that you see here. In this slide, you can see my references and the Eric references. I am Simone Meneghin. I'm a regional sales area manager. This is my email. My phone number is an Italian phone number, and this is my LinkedIn profile. Same for Eric. He's a product specialist engineer. Email, phone number, and a LinkedIn profile. See you soon.
Thank you very much, Al.